Hello everyone. Today in section 8.3, we're going to be talking about testing a claim about the mean. So to briefly go over the requirements, we have to have a simple random sample, we have to have the central limit theorem, and we assume that sigma is unknown for this particular case. If sigma was known, we would have to use a different test statistic based on the fact that we know what sigma is, we would use that instead of s, and we would be looking at a z-score instead of a t-value. Now I include this slide just in case you happen to use this in another class where they do take the case where sigma is known. And you can compare the two to see how they are similar or different. So for this example, we're looking at the dirt bike fuel capacity where we have a sample of 32 bikes and they have a mean fuel capacity of 1.91 gallons and a standard deviation of 0.74 gallons. So we're going to figure out if the data provides significant evidence to conclude that the mean fuel capacity is actually less than 2 gallons. In this example, we notice that our sample size is in fact large enough, so we can safely assume that we have the central limit theorem. We also have to assume that because they tell us it's a random sample, that this is in fact a simple random sample. And since they do not tell us sigma, we're going to assume that sigma is unknown. So the claim in this case is actually the alternative hypothesis. So that means the null hypothesis is mu equals 2 gallons, and the alternative is that mu is less than 2 gallons. The significance level is 10%, and if we use the formula to calculate the test statistic t, we find that the test statistic is equal to negative 0.688. With the critical value, we'll just rely on the table for now. So using the table, we get the critical value of 1.309. However, we know that this is on the left side of the distribution curve, so we have to put a negative in front of the number. So this is negative 1.309. Notice that the test statistic does not lie inside the rejection region, so this would allow us to conclude that we fail to reject the null hypothesis in favor of the alternative. To get the p-value, the only way you can really do this is by using some kind of technology. And in Excel, we can do this one of two ways. The way I'm going to show you how to do this is using the pre-made t-test. The other way is to use the t-distribution formula that's built into Excel as one of the functions. So in the Excel sheet, you just simply type in all the information that we have given to us, and then we select the less than mu naught. And it gives us both the test statistic, which we already found, as well as the p-value. And noticing that our p-value is in fact greater than alpha, we fail to reject the null hypothesis in favor of the alternative. And because the claim was in the alternative, we do not have sufficient evidence to support the claim. In this example, we're looking at the pH levels obtained from 15 different lakes, and we're going to figure out whether or not these are non-acidic on average. Since we are testing the claim that the Southern Alps are non-acidic, meaning that their pH is greater than 6, that means that that is our alternative hypothesis. So the null hypothesis has mu equals 6. The alternative is that mu is greater than 6, which is again the claim. And the significance level is 5% or 0.05. Since we're given the data values, I'm going to go ahead and just type these into Excel and calculate the test statistic as well as the p-value. Once I have those typed into Excel, I select greater than, and I get the test statistic of 3.459 and the p-value of 0.0019. To do the critical value approach, I just go ahead and find the t-value with degrees of freedom of 14 that has an area of 0.05 to the right of it, and we get the critical value of 1.761. And I noticed that the test statistic is, in fact, to the right of that value, or it's inside the rejection region. So we can reject the null hypothesis in favor of the alternative hypothesis, and we have sufficient evidence to support the claim that the Southern Alps are, on average, non-acidic. Well, thank you for watching, and I'll see you in the next video.